So in this video, I'm going to show you guys how you can compare different mortgages, find out how much you spent on interest, and which would be the better alternative, as well as how to build your own amortization table. So let's start off with this question. You are considering buying a house for no money down. The price is $250,000. Wells Fargo is offering you a mortgage with 4.33% annual interest, compounded monthly. What is your monthly payment if the loan is for 30 years? What is your monthly payment if the loan is for 15 years? How much interest would you pay over the life of the loan if it is for 30 years or for 15 years? What are the net present values of these interest payments? How much more would you pay in interest for a 30-year loan compared to a 15-year loan? So, the first thing you're going to want to do is put all your information on the left here. So, we know that our annual interest rate is 4.33%. And we also know that it's compounded 12 times a year. And it is for 30 years in the first scenario. So the number of periods is simply going to be the length times the number of times it's compounded, which will give us 360. Now the monthly interest rate is necessary because this is compounded monthly. So in order to calculate the payments, we're going to need to divide this by the number of times it's compounded, which will give us a monthly rate of 0.36%. So the present value of the loan is $250,000 and the future value is 0. Now in order to calculate the payments, we'll use the equals PMT formula. And the rate is going to be the monthly interest rate. The number of periods is right here, 360. The present value is 250, and the future value is 0. We'll leave the type alone because we'll just consider that this is going to be paid at the beginning. So that gives us a total payments of $1,241. Now to calculate the total spent, you just multiply that by the number of payments, which gives us 446,000 spent. Now, if you want to find out how much of that is interest, you can just take this and add the present value, and 196,000 is spent on interest. Now, if you want to do that again for the 15-year one, so the rate is the same. It's compounded 12 times a year, except this one is for 15 years. So equals this cell times this cell gives us 180. Now the rate is going to be the same because this is also compounded monthly. So the present value is still 250,000 and the future value is 0. So equals PMT, and we'll use the monthly rate, the number of periods, the present value, the future value, and that gives us payments of $1,890. So to calculate the total, we just multiply the payments by the number of periods, which gives us 340,000 spent total. And to determine how much of that is interest, we will just add this to the present value. So you can see a lot less is being spent on interest in this case. Now, if you want to create an amortization table, this will tell you how much is spent on the principal and the interest in each period. So you would first start by numbering these for each payment period. Okay, so here for the principal, if you want to link it back to this cell, this way, if you change your table, this will change along with it. So the monthly payment is what's in this cell. And you want to make that an absolute value because this cell is not going to change. The monthly payments are going to remain the same, so you might as well bring it all the way down right now. Then the next one is to calculate how much of that payment is principal. So for this, you can use another Excel formula called equals PPMT. So the rate is still the same. You want to make that absolute because this is not going to change. Period is the first period. You don't want to make this absolute because this is going to change with each line. The number of periods is this cell right here, so you want to make that absolute. And the present value is right here, so you want to make that absolute, as well as the future value. And it tells you that out of this $1,000 payment, 339 is for principal. So now if you want to find out how much of that is interest, you can use a similar formula equals IPMT. And again, you would want the monthly rate. This is going to be an absolute because you don't want it to change. The period is not absolute because you do want it to change. The number of periods is absolute as well as the future value and the present value. So $900 out of this monthly payment is interest. So now your balance is going to be your principal plus this amount, which was taken out of your principal. Gives you 249,660. So now for this cell, we wanted to always start at this cell. So we'll select that. We're not going to make it absolute because we want it to change. For the PPMT, we'll have to enter it once again. So the rate, once again, that will be absolute, but the period, because we want it to keep changing, won't. The number of periods, present value, and the future value will all be absolute still. And out of this payment, $340 went towards principal. So we'll do this again for the IPMT. use C15 as that. The number of periods are going to be absolute again. The present value is absolute and the future value is absolute. And as you can see, the amount of interest changed a little bit too. So the balance is going to equal the principal plus the amount that was paid off of the principal. So now once you've completed this second line, you can just copy this formula all the way down to the table. And it works all the way. So you can see how much out of each payment is for principal and how much is for interest. And as you can see, it goes all the way down until the last payment, where 1,237 is owed, and almost the entire amount is coming from principal with $4 from interest, and the balance is 0. So now, to do the same thing for this 15-year period, you'd basically just repeat the steps. And after you repeat the similar formulas for the second one, you will come up with a similar table. Now, the good thing about linking these cells is, say we want to change this to a $300,000 loan. All we have to do is change this cell right here, and it will change everything else because they have all been linked to this cell. And we could do a similar thing for this 15-year one. So change it to 300, and it'll tell us the payments required, and the amortization table will change to reflect those changes. So that was basically this lesson, and if that has been helpful for you at all, if you could please like and subscribe and recommend, that would be great. Thank you very much for watching, and have a nice day.